Hi, welcome to a nostalgic math chat. Today we're rambling about IEB November 2023, paper 2, question 9a. Let's go. Simplify the following into an expression containing only one trig ratio of theta. So this could be tan theta, sine theta, cos theta, etc. Okay, so we've got half cos of 90 plus theta minus sine theta times sine of theta minus 90 divided by cos squared times cos of 180 minus theta squared minus 2 times cos of negative theta plus cos of theta plus 90 squared. Okay, so there is a lot going on here. We are obviously needing to use our reduction formulae. There are some sneaky situations where the rule is 90 minus theta, but the angle is presented as theta minus 90, all of that good stuff. So I am going to experiment with a different approach. Let's see how well we go. If it's not popping, I'll just go back to using the reduction rules. But for obvious reasons, those reduction rules are many. So it would be good if sometimes maybe you're not able to remember what exactly the rule is, but you're able to derive it for yourself on the spot. And the key to remembering this is, the key to doing this is to remember that the ratios, suppose you have, let's use another color, suppose you have some angle theta, right? And we have, first of all, this arm here, which we call R, okay? The length of that line is R, and where that line ends, the coordinates are x and y, right? And the ratios are defined as follows. Oh, guys, it's almost midnight as I record this, so the English is resetting. Will be y over r, cos of theta will be x over r, and tan of theta will be y over x. So that's how the ratios are defined. So for example, where I'm trying to go with this situation is, if you have, let's look at cos of 90 plus theta. So let's say in your exam you've frozen up, you don't remember the reduction rule for 90 plus theta. You could maybe potentially just imagine theta as an acute angle. It's just easier that way, but in general the rules apply no matter what size theta is. But yeah, it's easy to, okay, I don't know why I'm in this habit of just repeating myself unnecessarily. Okay, so let's imagine that this is what theta looks like, right? Some acute angle in the first quadrant. So what does 90 plus theta look like then? It will be 90, right? This is 90 plus theta, right? So this bit here will be theta, this bit is 90. Okay, so this whole angle here will be 90 plus theta, right? And if we assume that, okay, this arm is also length r, okay, just imagine that, yeah, it's also length r. What are the coordinates of this point over here, right? So this triangle, if you imagine us completing this triangle like this, is really this triangle, right? Where we have the hypotenuse as r, right? It's also r over here. Okay, the 90 is here, the 90 is here. So this distance over here is this distance over here, right? It's almost like you've taken this triangle and you've tilted it this way. Like imagine you grabbed it over here and then you pulled it, rotated it, right? That's kind of what's happening. Anyway, so this is not y. That will be x units, right? Because it's the same as this. And this over here will be the same as y units. So the coordinates of this point over here, the x coordinates will be negative y, right? Because this y is positive, because our point is about the x-axis over here. But we can see that this point is on the negative side of the x-axis, so the x coordinate should be negative, so it will be negative y. And then the y coordinate will be x, right? So now this allows us to get the trig ratios for 90 plus theta, right? And we're more specifically interested in cos. So cos of 90 plus theta. Okay, we know that we get cos by looking at whatever the x coordinate is. In this case, it is negative y, and r, which is just r. So that is negative y over r, right? And what is that the same as? If we look back at the trig ratios of theta, it is the same as ding 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 sine theta, except it's negative. So it is the same as negative sine theta. So this is just an example of how you can still arrive at reducing this trig ratio so that it is in terms of theta instead of being in terms of 90 plus theta. I'm having fun, so I'm going to try it with another angle. Okay, so I'm going to see if I can shift some things. First, let us erase some things. I'm going to try see if I can shrink this guy. And hopefully as I do it for more and more of these trig ratios, hopefully it will make a bit more sense. I am pretty certain that it did not make a whole lot of sense when I did it just now. Anyway, right, so we have cos of, I'm just going to make note of them, cos of 90 plus theta reduced to negative sine theta, right? And yeah, so my aim is to try and write all the different trig bits in terms of theta. So the next one I'm concerned with is this guy, sine of theta minus 90. So let's do that one next. So again, supposing theta looks like this, we now want to figure out what does theta minus 90 look like. And these things are easier to work with if you start with the number and then add on the theta, right? Otherwise, if you start with the theta, for example, and then add the 90, it's just a bit more abstract to think about. Whereas if you start with the minus 90 just means instead of going this way, we are going to go clockwise, right? So that will be the 90, and then you just add on the theta. So something like that. So you end up in the same place. It's just a bit easier to figure out what the coordinates over there will be if this angle over here is theta. Okay, and also I'm speaking 0 because this would be minus 90 minus another theta. That would be going even more clockwise. So actually, hey, fetch my life. Okay, so let's think. But I still maintain. I think it's easier to start with the constant and then add on the theta. Okay, so we said that this is the 90. Okay, nice. Well, the minus 90 more specifically. And then if we add a theta, we're going to go back in the positive direction, which is anti-clockwise, right? So to the minus 90, go back a theta, if that makes sense. I hope that makes sense. So that will be somewhere like this. So this angle here is theta. Yes. Okay, right. So again, the goal is sorry, I just had a lapse in memory. The goal is for us to figure out the coordinates over here, right? And we know that, okay, this is our R. Oh, getting messages late at night, right? And again, we're going to like complete our triangle, right? So you look at this triangle as your reference, okay? Opposite to the theta is y units, yes? So this over here is going to be y units, okay? And then this other side adjacent to the theta is the x units, so this is x units. Okay, so that means that the x coordinate here is y, because y is positive and we are on the positive side of the x-axis, and the y coordinate will be negative x, right? So that looks like a G. Okay, so that means that, what are we interested in? Sine. Sine of theta minus 90 degrees is going to be the y coordinate, which is negative x, divided by r, right? And what is that equal to on this little map of theta's trig ratios? Well, it's equal to the cosine ratio of theta, except we have a negative, so it's going to be negative cos theta. Okay, and I'm also just going to highlight the other, I guess, the more how I would normally do this, not this little experimental route I'm taking. Oh my word, where did it end up? Yo, guys, what's going on? I don't know. Right, so another way that you would go about this is, okay, you would say, okay, sine of theta minus 90. But we know the reduction rules for 90 minus theta, so we would factor out a negative, which would result in a switcher rule. Okay, and then we know that sine of negative a is equal to negative sine a, right? That's another reduction rule we know, so this would be minus sine 90 minus theta, and then we know that this is the same as cos, so this is the same as minus cos theta. So arguably a faster way to get to the answer, however, requires more memorizing. Okay, so this is just another route that we could take. So option 1 and option 2. And option 2. Okay, right, so let's look at the next one. Wait, first we write down what we got. So we got sine of theta minus 90 is equal to negative cos theta. Okay, next one is this guy. Cos, so I'm going to first work out cos of 180 minus theta, and then, yeah, the square will just be the square of that. So, gonna figure out where is 180 minus theta. So, 180 is this angle, right? And then minus theta, we're going to go back up. So this over here will be theta, right? And this one is pretty simple to work out, like if this is our original theta where the coordinates are x and y, and this is r, so this is a reflection of this, right, in the y-axis. So what does that mean for us? That means that this is r. That means that the x-coordinate will be negative x, and the y-coordinate will remain as y. Okay, so then the cosine ratio of 180 degrees minus theta will be this guy minus x over r, which is the same as this guy, except it is negative. Right, okay, so let's shrink that and note it. So cos of 180 minus theta is equal to negative cos theta, and therefore cos squared of 180 minus theta will just be minus cos theta squared, which would just be positive cos squared theta. Okay, right. Okay, right. And then next one, we're going to look at cos of negative theta. So we have, okay, where is negative theta? So that'll be, if my theta is here, then negative theta is just going the other way. Right, so that'll be negative theta. Right, and again, if this is r and this is x and y, then this is a reflection, but this time in the x-axis. So now, oops, the x-coordinate will stay the same, but the y-coordinate will become negative. Right, and this is also then obviously r. So cos of negative theta will be this guy, x, over this guy, r, which is just the same as cos of theta. Right. So we have cos of negative theta is the same as cos theta. Oops. Well, I need to shrink it that much more. Okay, and then I think we just have one left. Okay, last one is this one, cos of theta plus 90. So we are trying to figure out, well, okay, and we did do 90 plus theta-ish, yeah. I'm too lazy to bring back that diagram, so let's just do it again. So like I said, start with the number, right? So this is 90, and then we're going to add theta to it. So there's our theta over there, okay? So again, we've taken this triangle and we've kind of taken this part, so hold the triangle and rotate it on around about the origin. So this, keep this point fixed and tilt this triangle until this part is over here and this part is over there. Right, so up here we have y, not y, why do I keep saying y? Okay, it's going to be x units, right? Because like I said, this part comes here, right? And then over here, it's going to be this part, which is y units long. There's going to be a problem. Let me write less enthusiastically. Y units. Okay, right. So the coordinates of this guy, well, firstly, this is R. The coordinates of this guy will be negative y, because we're on the negative side of the x-axis, and x for the y coordinate, right? And so cos of theta plus 90 will be this guy minus y divided by this guy, which is r, which is the same as this guy, except it's negative. So it will be negative sine theta. Okay, right. Ooh. Let's hope we make it, guys. Oh, we made it. I am becoming a pro. I mustn't sing my praises too loud, but I am becoming a pro. Okay, right. So the last one is, we said cos of theta plus 90 is equal to negative sine theta. And so therefore cos squared of theta plus 90 is equal to negative sine theta squared, which will be positive sine squared theta. Okay, so there we have our reductions. Right, so let us simplify our expression. So this will be is it even gonna fit? Why did I do this? Why did I do this? Why did I write on the diagram? I know not. Okay, what I can try to do is shrink some of them. Okay, I think I should have enough space. So this will be a half times this guy minus sine theta, and you gotta be so attentive to your signs, like positive, negative, not sign the ratio. Be attentive to that too, but yeah, I meant the pluses and minuses. Okay, and okay, so I just kind of substituted that one without really announcing it. And then next up we've got this guy, which is this guy, cos squared theta minus 2, and this is, oh, I don't even need a bracket. Cos negative theta is positive cos theta, so just going to write it like that. And then here we have sine squared theta. Okay, so this is minus half sine theta plus sine theta cos theta divided by, and what stands out to me is we have cos squared theta plus sine squared theta, which is 1. So I'm just going to replace that with 1 and see if that does anything for me. I'm going to then factor out, so I mean I see that there's a difference down here, and yes, and there's a common factor of sine theta here. So if I factor out sine theta, I'm going to be left with minus a half and plus cos theta here. So it looks like there's going to be an opportunity maybe to cancel things out. But in order to do that, I need the cos term to be negative. So I'm going to, instead of just factoring out a sine theta, I'm going to actually factor out a negative sine theta. And I'm going to also get ahead of myself and say, well, if I take out a half as well, then here I'll just be left with 1, which is good. And over here, well, what do I need to times a half with to get a coefficient of 1? I'll need to times with 2, right? So things are really looking good if I factor out negative half sine theta. So my first term will just be 1 minus, well, my first term will just be 1, and then my second term will have to be negative, and then I'll have to times with the 2 so that I end up with a coefficient of 1, and I'm also just left with cos theta as well. And then here at the bottom, I can just rewrite this as 1 times 1 minus 2 cos theta, just to emphasize that, you know, I'm turning the bottom into one term. We can only cancel if we have one term at the top, one term at the bottom. So we can now cancel away the common bracket, which is 1 minus 2 cos theta. And so this simplifies to minus a half sine theta. Right, and the beautiful thing about a question like this is you can then take any theta you please, any value for theta that tickles you, and see if the equation holds. So I'm going to choose theta as 223. So we have a half times cos of 90 plus 223 minus sine of 223 times sine of 223 minus 90. Okay, and at the bottom we have cos of 180 minus 223, and we're going to square that, minus 2 cos negative 223, oops, okay, and then plus cos of 223 plus 90, and we square that. Okay, so we're going to get some answer. Go calculator, go. 0.34 wara. Right, so now if we put 223 in here, we should get the exact same answer. So let's see, negative 0.5 times sine of 223 gives us the exact same answer. So we can have some confidence that we have absolutely smashed this question. Let's see if the memo agrees with our hype. And the memo agrees with our hype. So yeah, I don't know. I hope that showing you kind of a different, maybe sort of wacky approach to reductions was useful. Otherwise, let me know. I can do this question again using the more conventional approach, which is, you know, remembering your reduction formulae and applying those to each of the expressions that needed to be reduced. Cool. Catch you again another time for another ramble.